So what we're going to look at here is how we actually write chemical equations in an exam. It's important to remember that equations always follow the same general order. So if we learn off this order of equations, we start off with our general equation. So that's something which isn't specific, such as acid plus metal. It doesn't tell you what acid is or what metal it is. And these are the ones generally we have to learn off. After we have our general equation, we start to make it more specific. So we go to our word equations. So instead of just acid plus metal, we might be saying, right, okay, let's use hydrochloric acid and magnesium metal. So we're actually using those words. Then we go into a symbol equation, and usually in an exam it asks for a balanced symbol equation. It doesn't just say a symbol equation, and that's where we convert our words into our chemical formula, our chemical symbols. On very hard questions, they may ask you to go a bit further than that. They may ask you to write an ionic equation, or they may ask you to write a half equation. The ionic equations and half equations I'm not going to cover in this video. I'll cover those in a separate video which you can watch at that time. So here's a past paper exam question. Write out a balanced symbol equation for the reaction between aluminium and oxygen. Now we have to work through that same order of equations which we've just looked at. So we'll start off with our general equation. Our general equation for this reaction would be metal plus oxygen goes to the metal oxide. Our second step would be to go to the word equation. So instead of just having our word metal and our word oxygen, we're going to make it specific. Our question says we are using aluminium, so we write in aluminium plus oxygen, which goes to aluminium oxide instead of just metal oxide. Our next step then will be how we convert our word equation into a symbol equation. Whenever we're converting into a symbol equation, we have to ask ourselves two questions. The first question is what we're trying to convert as an element? Is it only one type of atom between the plus and the arrows? If it is, check the magic 7. That will tell you if it's diatomic or if it's just monatomic, i.e. it's just one atom. The other question we have to ask ourselves is, well, if it's not an element, is it a compound? If it's two or more elements bonded together. If it's a compound, then we have to cross our valencies. So let's put this into practice. Here again is our word equation that we worked out earlier. Aluminium plus oxygen goes to aluminium oxide. Now you'll notice that we've kept the plus sign and the arrow in the same place, directly underneath. Now what we're going to do is convert these things into our formula by looking up the periodic table. First of all, let's look up our symbols. As we can see, our symbol for aluminium is Al. So we're going to write in Al. Now the other thing we have to check while we're here is aluminium in the magic 7? Now in this periodic table, you can see that the magic 7 has been highlighted for us. Remember that the magic 7 is the 7 elements, 1, 2, 3, 4, 5, 6, 7, which are diatomic. To find our magic 7, we go to the element with atomic number 7, draw the shape of a 7, and we also include hydrogen. Those are the 7 elements which are diatomic. So as you can see, aluminium's not in the magic 7, so we just leave it as Al. Next we go to oxygen. So oxygen you can see is here. Its symbol is O. So we're going to write down an O. But you can also see that oxygen is in the magic 7. So oxygen is diatomic, and we must then put in a small 2 to mark the fact that it is diatomic. Lastly, we come to aluminium oxide. Now, aluminium oxide isn't like aluminium and oxygen, where it's an element, it's only one atom. Aluminium oxide is two different types of atom which are bonded together. So instead of having to check and see if it's in the magic 7, now we have to cross our valencies. So we do one of two things. We either check if it's in the magic 7 or we cross the valencies. We don't do both. If something is bonded and you're crossing the valencies, forget about the magic 7. So in this case, we have aluminium and we have oxygen. So again, we're going to write Al and O. Now we have to write down our valencies. So our valency for our aluminium, well, aluminium's in group 3, so its valency is 3. So we'll write down then, valency 3. Oxygen is in group 6, so its valency must be 2. So we write down a valency of 2. Can we simplify that? No, we can't simplify 3 and 2, so our last step is just to cross over our valencies. So we're going to cross them. Our 3 goes across to our oxygen, and our 2 comes across to the aluminium. So now our formula is Al2O3. Our last step is to balance this equation. I'm not going to go through that here because there's a separate video on that, and if you do want to know how to balance the equation, go and watch that video now.